I will explain the code for the assignment 3.1p. So this code is basically to modify the BST to track its balance. This is the tree node class. It represents a node in the BST. Each node contains a key, which is the value of the node, left and right pointers to its left and right children. I added two new attributes, height to store the height of the node and balance to keep track of the balance factor. Now the balance BST class. This class contains the methods for insertion, deletion and balancing of the tree. The insert method. This method inserts a key into the BST. After inserting a key, it updates the height of the current node and calculates its balance using the getHeight and getBalance method. If the tree becomes unbalanced, that is like the balance factor becomes greater than 1 or less than -1, the tree is balanced using rotation. I used left and right rotation to handle imbalances. The deletion method. This deletion method deletes a key from the BST and similarly updates the height and balance of the tree, balancing if it is necessary using rotations. The balance calculations. The getBalance method calculates the balance factor by subtracting the height of the right subtree from the height of the left subtree. The rotations. The left rotate and right rotate methods handle the rotation needed to rebalance the trees. They are called when the balance factor becomes greater than 1 or less than -1. Is balance is finally checked is a method recursively check if every node in the tree is balanced or not. In the example, this all it's that, and yeah, in this example, I inserted the case 10, 20, 30, 40, 50, 25 and then performed the in-order traversal to print the nodes along with the balance factor. Afterwards, the program checks whether the tree is balanced or not. Now the second code is to find the first common ancestors of two nodes in a BST. Yep, that's the code. And this is the tree class node. Similar to the previous example, I created a tree node class to represent each node. And binary search tree. It includes an insert method for adding nodes to the tree and a method to find the first common ancestors. The first common ancestor method. This method takes the root of the tree and two nodes as input. It recursively checks if both nodes are on the left or right subtree of the root. If one node is on the left and the other is on the right, the current root is the first common ancestor. And now, for example, we have inserted 28, 22, 4, 12, 10 and 14. And the function found that the first common ancestors of node 10 and 14 is 12, which will be the same answer if you draw the tree and get the answer. Now, performing the rotations in BST, all the four rotations. This is the node class, that's the BST class, and I have inserted all the rotations into this. So basically the left rotation method rotates a node and its right child. If the node has no right child, the rotation cannot be performed. Otherwise, it rearranges the nodes to maintain the BST structure. The right rotate. The right rotate method rotates a node and its left child. If the node has no left child, the rotation is skipped. Left right rotate and right left rotate. The left right rotate method first performs a left rotation on the left, followed by right rotation on the parent node. The right left rotation works similarly but in the reverse order. And finally, the in-order traversal helps to print the trees in a list manner. And yeah, that's it. We get the choices to fill up It can be like left rotation, right rotation, or any one of the four. And finally there is a function to exit the program as well. Here is the output. Yeah. And so for the fourth question, so that's the answer, and it's a theoretical answer, so I will just skip this one. I have converted it into binary and done all the necessary steps, and yeah, here's the output and everything. So by mistake, yeah. So yeah, this is the B tree, and this is the B plus tree. I have just followed necessary steps to get the whole tree diagram according putting up all the rules and following the methods. And this is the RB tree. I have made a clean diagram so that you can check it thoroughly, and yeah, there's no mistake in it as well. Thank you.